Hello, this is my Jupyter Notebook walkthrough. So this notebook's organized into sections: pre-processing, building a baseline model, and then comparing different models um, with different hyperparameters. And I wasn't really happy with basically everything I did up into F, so I kept going, and I'll explain it as I go through. Yeah, let's go. So pre-processing data. Um, I did some EDA here. Um, Most of the variables have the same cyclical nature as the Celsius degrees temperature that we're trying to predict, with the exception of the wind variables. Then I transformed it all using the z-score, converted all the data into a 24-hour in one line, 24 hours of each attribute in one line. Then I had to cut off the first value of x because I'm trying to predict t plus 1. So then I took off the last 24 of y, which because there's 23 values don't make up a row, and then that one I just cut off. So now each of the data. So this is the first data trying to predict, that one, and so you can see here perfectly that 2.1 is it's not predicting 2.1, it's predicting 2.11, it's the second value. So that's what I want. T plus 1. Then train validation set I split 70-30. Not randomized, just at a specific point in time. So I just cut off the rows after the 70th percentage of row count for my validation set. And then I built a baseline model, baseline LSTM model, 50 neurons, atom optimizer, 100 epochs, 72 batch size. Let it go. So that's what this is. There's a plot of the results. Then I experimented with different batch sizes, so 36, 108, 142. 36 took way too long to run. 108 didn't take as long to run, and got the lowest validation loss in here. So it's 0.7s. And then the 142 just seemed to overfit too much. So I went with 108. So a number of neurons, I did 25, 75, and 100. So this is 25 neurons, which seem to overfit kind of, but 75, I think, did the best because it had the less amount of overfitting, and then 100 had more overfitting, so I went with 75. Dropout 0.2, 0.4, and 0.6 for the three cases. In this case, it was like underfitting for the most part. For the other two, see, test way below the train. So I went with the least underfit model, which was a 0.2. And I tried three different cases of regularization, L1, L2, and then L1, L2, which is ElasticNet. The best case, or had the lowest validation loss, was the L1, L2 combined. But then these were all in isolation, so I wanted to combine them into different cases. So that's what I did here. So for each of these cases, I ran them 5 times. So case 1 has 200 epochs, but with 0.2 and 75 neurons, and then same as case 2, but L1, L2 instead of 0.2 dropout. Then the third one, I increased the number of neurons to 0.2 dropout, and then 125 neurons, but L1, L2 realization. So this was the base case, ran it 5 times, lowest was like 0.73. And unfortunately, I didn't really do much better than that base case. So in all of these, so for each case, it runs 5 times. And the best case was this one, which was like 0.73. So obviously did not do very well considering compared to my base cases. Yeah. So because of that, I decided to tune the best one, which was that 0.73, which was a regularization of 0.1 and 75 neurons. So I tried increasing the L1, L2 penalty, didn't really do better. So then I increased it a little bit more, went in the right direction. So then I decided to add dropout back in because it still wasn't getting where I wanted to go. So I ran for 500 epochs, added a dropout of 25%. Still did not do well. So then I discovered using a current dropout instead of just dropout, and then I slowed down the learning rate by making this number smaller, the eta value. So that's what I did. And then it started doing a little bit better, so that was good. So I increased recurrent dropout, did better. Then I kept increasing the recurrent dropout and the regularization penalty, and it did. The best that I ever got was this graph right here. So then I tried a few other things. I tried stacking LSTM models on top of each other. Fortunately, there was a considerable amount of overfitting, so that didn't work out for me either. So in the end, I was saving each model, each epoch. I was saving only the best weights for each model every time it would run. So that's what was loaded here. That point. That's why you see that 0.6044 number for the weights. And then I, loaded the X test data up. Converted it, reshaped it, predicted using that model, and converted it back to temperature, not from Z. Put it in the right format, and then exported it. So yeah, so that I could submit to the Kaggle file. Thanks for a great class. I learned a lot. Bye.